Welcome to the talk about the Darknet of Things. Can everybody see the slides okay? Everybody read them? Cool. All right. First, a couple introductions. I'm Anch, also known as Mike, or Hey Asshole. I respond to any of those. This is Omega. He is not known as Hey Asshole. Say hi.
Hey, hello.
Okay. We are here to talk to you a little bit about what we've built in a project that we're hoping you guys will help us with, and get involved a little bit and have a little bit of fun. So let's first talk a little bit about the Internet of Things. It's thrown around a lot. You know, people think that connecting your fridge to the internet is a really great idea. Only if you want your temperature controlled by hackers. That should be fun. We're not talking about your fridge here. When we talk about things, we're talking about a network of things, not things on the internet, okay? There's a huge difference. I'm not going to take my garage door and attach it to the internet and call it the Internet of Things. The garage door is just a thing on the internet. It's just another network connected thing, right? So what we're talking about is actually building networks of things that do interact with one another, things that actually build their own networks and talk to one another and create a network of things. So let's talk a little bit about sensor networks and what they are. So we have a bunch of little disks up here. We'll talk a little bit more about what we built a little bit later, but basically what we have here is a small sensor network, and the sensor networks take information, they pass it to one another, and usually compute a little bit of the information and send stuff. Wow, really? Okay, anyway. Yeah, I'm gonna have to talk louder, I guess. They send stuff back in order to be interpreted by a central node, and that central node is usually a part of the sensor network itself. That's what they're supposed to do. What they're usually used for are industrial controls, manufacturing, tracking of equipment, things like that. They're usually pretty small. As far as we can tell, some of the largest networks, sensor networks, independent sensor networks are around the 300, 400, 500 sensor stage, and then they break off into other networks. Oh, that is the next slide. Sorry, my laptop has a presenter view, and it wasn't working with the projector, so I've got the same view that you have up here, so I can't tell what's next. So it's a little bit fun thing. So there are several things with sensor networks. First off, Zigbee is a protocol, it's a sensor network protocol that is designed for small sensor networks. They mesh, they do a lot kind of stuff. Well, there's also another protocol called 6LoWPAN, and 6LoWPAN is basically IPv6 for sensor networks. So we can actually run on these little guys here a full wireless IPv6 stack. They have a full IPv6 network, they're pingable, they mesh, they do routing, all that kind of fun stuff. And so it's designed for it. And some of those advantages are it's a very, very large address space, right? I have a IPv6 tunnel with a /48, and I have something like, I don't know, there's a lot of zeros after the number of addresses I have. 65,000 /64s, and the /64's got 6 billion addresses in it, you know, so I've got 65,000, so yeah, quadrillion, or I don't know the name of the number. He does.
I don't.
No, he doesn't. So there's some serious advantages to that. I mean, we've got large address spaces. We got a large number of sensors that we can put on an address, and they're all addressable at this point. Some of the limitations are it's low bandwidth, high latency, typically. So, you know, the amount of data that I can push across these networks is very, very limited. In fact, we'll do a little demonstration up here in a little bit, and when I send a packet to these guys, I'm sending like 2 bytes. I mean, it's really, really small. I think my max MTU is 182 bytes, and that's you know, that causes a lot of big problems when people are trying to do large packets on these networks, because they fragment and they do all kinds of funky stuff. If you want to know more about 6LoWPAN, come talk to me afterwards. I'll go into some pretty deep detail. I don't want to glaze everybody over sitting here. Oh yeah, they swapped. Wow, that's cool. So this was supposed to be before the last slide, but that's okay. We'll figure it out. So we talked a little bit about Zigbee too. It's low power wireless network, and the advantages are that it's really simple to do. I mean, you turn it on and it essentially works. They talk with one another. Limitations are the number of sensors you can have on the network is really, really relatively low.
Zigbee isn't routable. It's not IP. So
talk closer to the microphone.
Zigbee isn't routable. It's not really IP, so you can't get to it from anywhere else. It's just a tiny little network, and you have a access point, and you have to bridge the protocols, all kinds of stuff.
Yeah, I was actually poking these from the internet the other day. It was kind of fun. So, what are we doing up here besides sitting up here, you know, looking at all you guys go, we developed a project, and it's a project for all of us as a community to work on. It's not something that we're trying to keep exclusive rights to or sell exclusive rights to or anything along those lines. We're trying to turn something up that we can all kind of have fun with, and we want to build a Darknet of Things. We want to take hardware hacking to the next level. Everybody here likes to hardware hack and all that kind of stuff. We got these really cool badges that Lost made this year. Everybody give a hand to Lost. He put a lot of work into these, and really? Seriously? Oh man. Okay. Yeah, it is my bullshit. Anyway, so you know, we really want to do something between now and next year that's going to make next year at DEFCON 21 awesome. And so we want to build the largest free roaming sensor network in the world next year, and we want your guys' help. Okay? It's something for all of us to do, and it's something that all of us can take pride in next year when we're all walking around with shit that we built that's all talking to one another, and we're all having a good time. Here's some considerations. No Arduino. None. We're not building this on AVR. We're not going to build it so you can hack it with Arduino. We're not going to build it so it's easy to use. We want you guys to actually learn something and have a little bit of fun. Arduino is, quite frankly, very much overdone.
And underdone. It's got some definite technical problems. The pinout is rather awkward. You'd think they could have made it much more normal, but they didn't. The software is it's okay. You can do some stuff with it, but it's common problem is you try and use a standard library, it's too slow, it doesn't have the right API, you write your own, and then you're stuck with the chip that you chose because the Arduino is changing chips about every rev. I've seen a lot of cool stuff, but I haven't even touched it personally.
How many of you guys have an Arduino?
Wow.
Yeah, you fuckers already know it. We want you to learn something new, okay? So we'll talk a little bit more about stuff that we're planning here in a little bit. Our stuff needs to be hackable. Okay, it's a hacker conference after all, right? So we want you guys to be able to hack it and have fun with it. It needs to be modifiable, changeable, bendable, but yet still we need to have it a little bit stable. We need to be able to maintain it. We need to be able to fix the shit if it breaks. And shit happens at con, right? You guys all know that you'll get, you'll get this and, well, you'll short it out and blow it up. Or you'll build something and somebody will come along and pummel the network so it won't work. So we need to be able to do that. So it needs to be maintainable. It needs to be a network of things. We're not going to put things on a network. So we're going to build our own network of things. Will we have off points to the DEFCON network? I hope so. I'm going to talk to Lockheed about it and see what we can do. It needs to be free roaming, so they need to be wearable, movable, pocketable, stuff like that. We've already been talking with some people. We have some ideas. We mocked this up. These aren't functioning yet. We haven't put code on them, but these are really, really cool. It's essentially a wearable badge. It's got a 2.8-inch TFT touchscreen on it. I'm going to burp. Just a second. I love drinking beer while I present. It's fucking awesome. No, I'm not that gross. We also want these things to be able to work outside of DEFCON. I have a collection of electronic badges sitting in my office at home, and they all work, but they don't really do very much outside of con. It's not like I put them on and I go prancing around the city wearing my DEFCON badge. That would be kind of stupid. But we want things to be able to work at home and at other hacker spaces and be able to have you guys be able to play with the stuff that you've built at home and still have it interoperate. And so we're also going to provide some of our other hardware, some access points and development hardware, things like that early on, so you guys can actually build this stuff at home, test it, make sure it works before you bring it to con next year. So let me turn this over to Eric. He's going to talk a little bit about the hardware. I'm actually going to slide over so you can control the slides, because you don't want me doing this kind of shit.
So the badge that we mocked up is, as he said, it's a 2.8-inch LCD touchscreen. You can get them from eBay for, what was it, 15 bucks? Quantity one, so they're pretty cheap. It's built, the network is built around a radio chip that is a single package, 802.15 class radio, and a microcontroller, and all the antenna matching, everything else in one package. It literally needs a crystal and an antenna and power, and that's about it. So that makes layout very easy. If you've seen a lot of the radio boards out there, the XB and the Nordic Semi stuff, there's a huge number of little discrete parts in there, very specific antenna matching. Yeah, it's just easier to put it in one package, and Freescale's managed to do it. It's a pretty quirky chip, but it works so far. The rest of the badge consists of a fairly high-end LPC, was it 1778? So that's a 120 megahertz ARM. It's got a memory bus, so we have a SD-RAM on here. This is 2 megabytes. You can go up to like 64. Touchscreen controller, because there's no way I'm getting analog into the main micro and making that work. SD card, 2 USB ports, host and device, and OTG, I think. Theoretically battery powered, but we haven't gotten that far yet. And an Ethernet site, so in theory you could hang an Ethernet cable off your badge. That might not work so well, it's pretty heavy. JTAG header here, you can see it on this one here. Standard JTAG header on this badge. That might be a little sharp for a badge. I've heard comments that even these things are kind of sharp, and not sure I would want to lug that around. We're going to be posting the tool chain, the schematics, all that stuff on the DCG Darknet site. And we hope that you hack on it, modify it, do whatever you want, make your own badge, make it work. And Yeah, so there's basically the summary. We have not routed out much of the extra peripherals on the part because we just wanted to get this thing going, but there's a lot of peripherals on this chip. You could do a lot of stuff with it. There's a sound interface. We're planning on putting an accelerometer on here, or all kinds of stuff. So in order to ease development, we put together this very simple adapter. It's the chip, the antenna, JTAG, and some pins. Because it's a full ARM microcontroller on here, you could write an app to do whatever you want. For instance, I want to put one of these in the basement of my house, controlling the dampers on my air duct. So I have my own little zone system. And being on the IPv6 network, I can control it from my computer, I could control it from my phone, I could do whatever I want.
And so can I.
There's the problem, yeah. Is that us?
Yeah, that's us.
Maybe that'll help. It's got UARTs, SPI, I2C, take your pick. There's a bootloader on here, so if you you get a standard USB to serial adapter, you hook it up, a couple of pins, and you've got yourself a loader. You can talk to the computer, you can run slip over the thing. That's how you get slip IPv6 into your computer. You can route it. It has this tiny little JTAG header, which is a bit of a challenge. You have to get an adapter, but it's not too big of a deal. Bootloader is your friend. And then the moat that we built a bunch of. This is, again, it's pretty much just the chip. It's got a button, an LED, and a battery. And we're going to demo putting these on the desk here and turn the lights on.
Yeah, the way I've been describing this to people is this is a wirelessly connected IPv6 LED throwy.
Yeah.
It has a little LED on it and a button and not a whole lot else. It's got the serial port out for it, so you can actually attach sensors and stuff to it if you want. We will actually have these in Q&A for people that want to help us recoup our hardware cost. And we have these and we have kits and we'll give them to you for a little bit of an exchange. The other one, we didn't build this one. We actually have boards printed, but we didn't populate it. This is essentially an access point.
Yeah. It's Ethernet. It's not PoE. That'd be nice, but that's kind of big. Basically, you drop it on a board. You could not even populate the pins on the side, plug it into your network, and you've got yourself a V6 bridge. We could even put a tunnel on the thing.
Now imagine the evil things we could do with this. So this is an IPv6 access point, essentially, that if I have this and one of these, I can create an IPv6 bridge that's wireless that's not going to show up on your wireless intrusion prevention system. Can you have some fun with that or what? All right. So we're going to do a little bit of a hardware demonstration here. And I need my other piece. I'll have to plug it in here in a minute. So I'm going to give my standard disclaimer about live demos. This is actually a live demonstration. We have not recorded this. We have not attempted it in this room. We have attempted it other places. Whenever we do live demos, so whenever I do live demos, something always happens. I have made several beer sacrifices to the demo gods. I'm hoping that they work. We've had some success with this stuff earlier today, and it's been pretty fun. But yeah, so that being said, here we go.
You have a cable, right?
Yeah, I got to get my cables out of my bag. So let me have the tribble. This is my friend Eddie Mize's tribble, and I thought that was pretty funny. It's because it's in my pocket. Yeah, that is what she said. So basically what I'm going to build here, real quick, because I don't need the programming cable, I'm going to start a slip bridge between my laptop and one of the development boards we have mounted on a breadboard. And this development board is attached to a USB to serial interface. It's 5 wires. There's 5 wires to this board. It's hard to see, but we'll show anybody that wants to see later in Q&A. But basically, if I plug this guy in, and VMware works right. There we go. Okay. And fire up the, oh. Everybody don't look, I'm entering my password. All right, so we have a IPv6 bridge here, and let's hope Goatsy doesn't come up. And we see that this guy is a border router. He has no neighbors and no routes. So Eric is going to start putting batteries in these little motes here, and we should see them pop up. And they take a second to boot. And start to communicate with one another. Pray to the demo gods. There we go. Look. See, we got a couple of neighbors, and we have a, yeah, we'll have 4 here eventually. There's 3. And we have listed the routes for the neighbors. Does everybody read that okay, or do I need to jump the font up a little bit?
Plus.
Alt plus?
I don't know.
I don't know. I don't either. Control up. There's that better? Okay, well, I can do it one more time.
Should have 4, and now 5.
There. I love an interactive audience. It's so much fun. Okay, so, sorry. What we have on these, running on these motes actually right now is a version of Contiki with a RESTful, a small COPE server on it. And what COPE does is it takes a couple of little interactions, and I can do some things with them. So I'm going to start turning LEDs on here as soon as I start the correct web browser. And we will copy this address, and we go here, and we'll go everybody dance to the music next door. Oh, yeah, we have to put brackets around IPv6 addresses because Firefox doesn't understand them, neither does Chrome. Say that again? Oh, I missed the last 4? Okay. Oh, I did miss the last 4, didn't I? Thank you for catching that, because I would have been up here scratching my head. Oh, fail. All right, here. Notice that, there's an homage to my friends here. All right. As you drink, the presentations get harder. Yeah, I was hoping that was coming. Okay, there we go. That's a little bit better. Okay, so what we got here is basically I've got a console to cope. And so I can discover this moat, and it tells me that all these things are available to me to either read as a sensor or use as an actuator. And what we want is the LEDs. So I'm going to put the color here, which I hope is red. The color is red. I'm going to tell it that I want to turn it on. And I'm going to put it. And I got content, and I got this one right here.
It is.
So the advantage to these guys is they'll actually mesh with one another. No, I don't want to attempt it. I got one good demo out of the demo gods. I'm not going to get another one. But they'll hop one another, and so we'll be able to read them going out. And so we can actually really have a whole lot of fun with these. We'll be around the next couple of days to have a whole bunch of fun, and we can help you have some fun with them. I have been told by Lost that there are actually power and ground headers on the badge, and so if you get a moat, we can actually put them on the badge and have them powered by the DEFCON badge and do some fun things with them this weekend. Okay. We don't have very many, unfortunately. They're kind of expensive to build. Anyway, so with that, I think I'm going to go back to the presentation because,
Where are we?
yeah, we've got about 20 minutes or so. So we're not doing too bad, but. So can everybody see the potential to this? Can everybody see how much fun we could actually have in a space like this with this many people sitting around and having things to poke at different people? And there's potential for fun and for profit. I mean, you could build these things pretty simply. It doesn't take very much for us to put them together.
That's about a $9 bomb on this in small quantity.
It was a little bit more than that, but
Okay, $9.50.
come on, it's more like 15. Anyway, but
Small quantity.
yeah, you're talking quantity. But we didn't have these made in a fab house. We had the boards printed for us, and we got them, and we used a toaster oven to do all the surface mount parts. And no shit.
EGA in a toaster.
Yeah, BGA. This man works hardware miracles. He's really good at what he does. And so we actually built these in his attic upstairs.
Yeah. A couple hours.
Last week in a couple hours. And so they're not too terribly difficult to build. And so everybody can do it. It's just a matter of actually doing it.
Dental pick, tweezers, solder paste, $25 toaster. Done. Well, in a few hours.
Okay. Now we're going to get to the fun part. Why we actually are giving this talk today, and how you can get involved. We felt when I say we, I mean Eric and I and some of the other members of some DEFCON groups and some other people that we talked around last year, felt that the community needed a common project to bond around and to build upon. And given that common project, I think we as a group can do fun things. I can say that I'm not really a hardware guy. I'm a pen tester by trade. But getting to the hardware and learning this has taken us kind of 2 years to put together. But learning that the last 2 years has made me a better pen tester. Getting close to the hardware has taught me a lot about how things work, which is what it's all about. We want to learn how things work, right? Is that why we're all here? Yes. Yeah. So, learning how things work is important to us. And so it's really kind of helped me become a better pen tester, and it's helped him become a better teacher. We also want to break people out of the Arduino rut. I see a lot of projects at our local hardware hackers group called Dorkbot, which, do we have anybody from Portland in the audience?
Go to Dorkbot.
Anybody go to Dorkbot? Okay, go to Dorkbot. It's every other Monday at Backspace at 7. Really starts at about 8:30. We're hackers after all. We're always a little bit late. So we wanted to break people out of their Arduino rut. I've seen a lot of projects based on Arduino that are really cool. They do some really cool things. I think you can get a quadcopter now based on Arduino, right?
Yeah.
Yeah. Could you imagine a quadcopter built out of one of these with a gigantic antenna? I'm going to build a drone.
Of quadcopters.
I'm going to build a drone for next year for DEFCON. I'm going to have it buzzing people in the contest area. It's going to be fucking rad. What's that? Oh yeah, it'll be on the internet. Damn straight it'll be on the internet. It'll make anybody be able to buzz people in the conference area. It'll take requests. That pyro guy, I hate that fucker. No, I really don't. I really love him. He's like a brother to me, but anyway. We want to expose people to a new chip, a new set of chips, and something different to work on with different possibilities. Doing that makes us better at what we do, makes us more able to do different things and to learn new things. I'm getting old. It's really, really hard for me to learn new things. But yeah, I look so young. Yeah, that's bullshit. Bullshit. I don't look young. I feel old. Anyway, compared to all you guys out here that are like 22 and at Vegas getting drunk every night, I'm having trouble keeping up this year. Anyway, and we wanted something different and fun to work on. That's really what it's all about, is fun. Having fun, building something that we can as a community, as a whole community, we can take part in and have some pride in. So the goal of the Darknet of Things, we're going to build fun things next year that operate as a Darknet of Things. It's not going to be super accessible to the internet, because I don't want people fucking with it in Israel or China, or we're going to keep the APT out, okay? You, sir, get an energy shot. That was fucking awesome. And we're going to produce these for next year. This is something that we've kind of had a dream of doing for quite some time. I don't know how many of these we're going to produce. All kind of depends on how much funding we can get, because they're pretty fucking expensive. But yeah, actually, that was actually my next word out of my mouth. Where are you? Raise your hand. Who said Kickstarter? There he is. Here, somebody get this energy shot to him. Here, I'm just going to throw it at you. Watch your head.
Oh!
That was fucking close. No, I don't throw beer. That's alcohol abuse. That could actually kill somebody. All right. So what we want to know is, what are you guys going to do? We have some resources set up now to help. We're going to continue this next week. Actually, it's going to be 2 weeks for me, because I'm going on my honeymoon. Yeah. Contrary to popular belief, there are girls at DEF CON. One of them's my wife, and she's fucking awesome. Anyway, the other one is his wife, and she's fucking awesome too. And so here's some more information. We've got DCG Darknet.net, and the website itself is IPv4 and IPv6, and you're able to get a hold of it, and you're able to go look at it. There's not a whole lot there. It's a WordPress blog. Don't hack my shit, please. Thank you very much. I realize it sucks, but it's, huh? I'm asking them nicely. Hackers are nice people. Yeah, I know. I'm sitting up here grinning my ass off because I'm hoping you're not going to hack my shit. Actually, it's pretty secure, so don't worry about it. Don't test that.
Famous last words.
I'm going to go shut it off right now. Actually, give me just a second. I'll shut it off right now. Dev.dcgdark.net. It's IPv6 only. Because this is, actually right now it's not IPv6 only, but it's going to be. The reason why I'm going to make this IPv6 only is we want you guys to actually have a working IPv6 network before you start to develop any of this hardware and get the code. That's the first step. Really, you need to have that in order to do any of this stuff anyway. And so if you're gonna try to leap and grab the code before you have it working, you're gonna have a lot of problems. And so this is gonna save us a lot of headache and heartache. So working IPv6 connectivity is a requirement. Go get a free tunnel from Hurricane Electric. They're awesome. The instructions out there are really, really good to set it up. You can set it up on just about anything. OpenWrt is great for it. And just go to ipv6.he.net and they'll tell you how to do it. This is something that Eric is passionate about. And so I'm going to let him talk about it a little bit. You have about 3, 4, 5 minutes.
I'll be quick.
Okay, be quick about it.
So, Mike here has been trying to set up a development environment. How long have you been at it?
Most of 6 months.
Yeah. So, we have a tool chain, GCC, bin utils. They work fine. Everything else, not so much. If you've developed anything for the Arduino and actually not used the IDE itself, if you've written straight for the AVR, it's really simple. You do gcc-m mcu at mega328 and your files, and you're done. Everything just works. It brings in the register headers, the linker scripts, the vector tables, all that stuff. And you don't have to think about it. In the ARM world, as it stands right now, for about every single chip, yeah, well, you could just show the
I'm not going to show
notes.
your notes. I'm going to turn more LEDs on. I have fun with that. I'm going to turn more LEDs on.
Oh, okay. When you're writing for an ARM chip, there are 10, 12 different manufacturers. Each of them have several different lines. They have different variations of those chips. There's no consistency whatsoever. When you pick a random chip, like we went with the LPC 1776, we look out there, we find that, okay, somebody's developed something with the 1374, whatever it is, and they have the project. It has make files that are usually abysmal. It has the linker scripts. They probably copied in the register headers from the IDE that NXP put out that I hate IDEs personally. And you end up with this chaos. You have to copy all the files that, at least in the AVR world, just come as part of the tool chain. Hey, there's nothing. You have to copy them into your project and you have to maintain them, and most of the time you go download an example and you find 3 or 4 and one of them is kind of close. So what's needed is some kind of consistency in the tool chain. It means some fairly minor modifications that AVR's already done to GCC bin utils to make it know where these files are. We actually need a collection of these files that actually all work, because a lot of the stuff the manufacturers put out are not so hot.
No, I just was at the wrong spot.
This isn't really hard stuff. It's just kind of tedious. You have to gather all the chips. You have to gather all the register headers. You have to figure out if we want to come up with a standard style. registers for peripherals in the AVR world, they all pretty much work the same way. They all have the same name. We were looking through the code trying to get this LED working on here, and they've got like 4 different layers of just GPIO code, and all of them are really weird, and they're built on top of each other.
So for people like me that used to be really ignorant of what a GPIO is and don't know and want to learn, tell them what it is, please.
GPIO is general purpose input output. It's literally the pins on the chip. Chips like this come with multiple peripherals. They have serial ports, LCD interfaces, SD-RAM, all that stuff. GPIO is the default operational mode for all the pins on the chip for the most part. So if you actually want to talk to stuff, light up LEDs, that's what you use. It's a really simple thing. You set the direction of the pin, you set all the, really, it's just the direction and whether the pin is high or low. And you're looking, oh, it's over there.
Oh, I didn't realize you put them over there.
Oh yeah, I spread them out. Really simple thing. They built layer upon layer upon layer of API on top of this thing, and I have trouble untangling what the heck Freescale did. It's unnecessary, and if I went to go to another manufacturer, they would have their own other insanity. They have this thing called CMSIS, which I have no idea what it stands for, but it's supposed to be some kind of common API across all ARM peripherals. It doesn't work. It's just...
It's bullshit.
Yes, it is. It is horrible. If you're programming a microcontroller, you kind of ought to know what the chip does and not use a, it's like programming a 8-bit micro in Java. It'd be that's kind of what they're trying to get you to do. So we kind of need to wrest control of all this stuff back from the manufacturers, because they don't care about the other manufacturers. They don't care about consistency. And without consistency, developing stuff like this is a pain in the ass.
So what are we going to do about it?
Well, we need to get a group of people together who actually care about this stuff and start hacking on it.
He wants us to build a consistent development environment like we have for AVR.
Yeah, it's been done before.
Which can be done. We have software people in the room, right?
Just a few.
Yeah. So we can do it. Power of, the power of people that are here. Really, as a community, we can do anything. And so we really want to, we really want to get this done. It's going to make our lives easier as we go on. So, how can you get involved? There's a couple of things. How many people in here are involved in a DEFCON group? I'm actually pretty passionate about this. I just came from a panel on DEFCON groups. Anybody? Raise your hand.
Yeah.
Involved in a DEFCON group?
2, 3, 4.
Oh, come on. Converge, where are you? No, he's not in here. Okay. Anyway, start one. Get involved. Find your local DEFCON group. If there's not one that exists, start one. Join one. Have fun. Get together with your group local. We are willing to do for these. I'm really feeding back really bad. There we go. For these, we are willing to do custom artwork. We'll put your logo on it if you're a DEFCON group. So we'll put your logo on it. If you're a group and you're a registered group and you're all good, let us know. We'll put your logo on these for next year. You can walk around being cool. Anyway, yeah. Get some hardware. We've got
a bunch of these.
We've got some of these here. If you give us your email address,
go to the site.
We'll email you when we have more, and we'll mail you some.
25-ish.
And yeah, well, just come talk to us at Q&A. We'll gladly sell you some of the stuff that we have up here in order so you can start. We only brought a little bit with us because it's kind of expensive to foot out of our own pockets to build a bunch of hardware to give out or sell or whatnot. But if you're really passionate about it, we'll be in Q&A after. Come and talk to us. We'll get it in your hands one way or another. Okay. We have the bill of materials and the schematics. We'll have the Eagle files available. All that kind of stuff we'll have on the website, freely available. You can grab them, print your own boards, put your own shit together, or even just make your own. Be a part of this, be a part of the community, and have some fun with this. My last point here is learn, hack, have fun, and then teach. I always put teach at the end of things because we as a community, I think, keep a lot of our shit private, right? I don't want him to know that. I don't want him to know how I broke his password because I'm super uber elite. Bullshit. You're elite if you teach somebody else how to do it. DEFCON 101, people that are sitting in DEFCON 101, Highwas is a good friend of mine. He says get involved in the community, ask questions, talk. That goes both ways. If somebody comes up and asks you a question, don't look at them in their face and go, who the fuck are you? No, answer their question, have fun, teach them something, and they will teach you something back. None of us are great at everything we do. We have photos. We have them with us. Just come see them. Big thanks. I have a lot of people to thank here, especially our wives. They're sitting up here in front. They put up with our bullshit on a weekly basis, sometimes more than weekly. We actually do something together we call Hack Night, and so we get together and have some fun. Russ, is Russ in here? No. Russ and the DC 719 crew, Russ has given me a lot of ideas over time. And so we're actually developing something, talking about something for next year with all this stuff, which would be really fucking cool if we could pull it off. DC 503, you guys representing here, there's a few of us. You guys
Dorkbot.
And Dorkbot, of course, Dorkbot.
Dorkbot is where the group order for these PCBs comes out of.
Yeah, if
These
you want more,
PCBs are cheap and fast.
if you want more, come get it. Come ask us about it. We'll give you more information. And of course, your mom. We won't go into what we're thanking your mom for, but thanks. All right, we have like 3 minutes, so we're going to see everybody over in Q&A. Come talk to us.
Buy hardware.